What do you use every day to help cook food, to heat or cool your home, to help transport you from one place to another, and to keep your body running? That's right, energy. But what exactly is energy? What forms does it take? And what are some of the different types of energy? During the next few minutes, we're going to answer these questions and others as we explore the fascinating topic of energy. We can't really see energy in the same way that we see objects around us, but it is possible to see what energy can do. Energy is the ability to do work. Work occurs when an object is moved or changed. Describe it. Describe how work occurs on this bag of groceries. The bag is lifted from the floor to the counter. In other words, the bag is moved. Energy was needed to do that work. So, as you can see, energy and work are closely related. There are hundreds of examples of energy at work around us every day. There are two main kinds of energy: kinetic energy and potential energy. Energy is considered kinetic or potential depending on whether or not an object is moving. We see moving objects all the time, such as cars, balls, and even people. These are examples of kinetic energy. Kinetic energy is sometimes referred to as energy of motion. Objects with kinetic energy can do work. This moving hammer, for example, performs work when it drives a nail into wood. Every time we move, eat, talk, and write, kinetic energy is at work. You decide. Does this container have kinetic energy? No, it's not moving, and therefore it has no kinetic energy. But it does have the potential to move if dropped. Potential energy is the energy an object has due to its position or its shape. Sometimes potential energy is described as stored energy, or energy ready to be used. This roller coaster is nearly motionless, but it has lots of potential energy because it's positioned at the top of the track and will soon lunge downward. Similarly, this stretched rubber band has potential energy, as does this compressed spring. Let's now take a look at some of the different forms of energy. Kinetic and potential energy have a variety of different forms. You're familiar with many of these different forms of energy, and you use some of them every day. For example, when you skateboard or ride in a car, you're experiencing a form of energy called mechanical energy. Mechanical energy is associated with motion or movement. Thermal energy, sometimes called heat, is another form of energy. Thermal energy is the total energy of particles in a material or substance. You probably know that matter is made up of small particles that are all in motion. Thermal energy increases when the particles in an object move faster. For instance, ice cream melts when its thermal energy increases. Chemical energy is another form of energy. You predict what will happen when a flame comes in contact with paper. That's right, the paper burns, and it gives off heat energy. This occurs when energy stored in chemical bonds are released within the paper. Explosives such as those used to blast rock, wood, and even food are all examples of chemical energy. Our bodies need chemical energy on a regular basis. When an engine burns gasoline, it's using chemical energy. The engine then produces both mechanical and heat energy. Take a second to look at the lights around the room. The lights are emitting another form of energy called electromagnetic energy. Light energy, a type of electromagnetic energy, is essential to the survival of most living things. X-rays, radio waves, and microwaves are a few other types of electromagnetic energy. Every time you talk with someone or listen to music, you're experiencing sound energy. Sound is the result of the vibrations of particles in a solid, a liquid, or a gas. People and animals hear sound energy with their ears. The last type of energy we'll discuss is nuclear energy. Nuclear energy is created when the nuclei of atoms are fused or joined together or are broken apart. Nuclear energy is the source of energy in the sun, and it's even used here on Earth to help generate electricity in nuclear power plants. You eat food to provide your body with energy so that it can carry out its functions and do the things you enjoy. Plants use light energy from the sun, along with water and carbon dioxide gas, to create the food they need. Both of these examples involve energy conversions. Energy conversion involves the change of energy from one form to another. You decide what energy conversion is occurring in this toaster. The toaster is converting electrical energy into heat energy, and heat energy toasts the bread. The rushing water tumbling over Niagara Falls is an example of mechanical energy. This building contains devices called generators, which convert the mechanical energy of moving water into electrical energy. Most electricity that we use is produced by electrical generators. All over the world, huge amounts of oil and coal are burned every day to convert chemical energy into heat energy. This energy is used to warm houses, power engines, and to generate electricity. However, one of the problems with burning fuels such as oil and coal is that harmful pollutants are given off in the process. Those pollutants can damage the environment. One of the challenges that scientists face is to develop energy sources and energy conversion processes that are environmentally friendly. During the past few minutes, we've explored the fascinating topic of energy. We discussed the relationship between energy and work. We compared kinetic energy, the energy of motion, with potential energy. We briefly explored the various forms of energy, including mechanical energy, thermal energy, chemical energy, electromagnetic energy, sound energy, and nuclear energy. Last, we discussed how energy can be converted from one form to another. So, the next time you play a sport, flip on a light switch, or eat, think about some of the things we've discussed during the past few minutes. You just might look at energy a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1 is the ability to do work. Number 2, the energy of motion is called energy. Number 3, the stretched rubber band has energy. Number 4, an engine burning gasoline is using energy. And number 5, energy involves the change of energy from one form to another.